In this video, we're going to learn how to use an RC servo. For more information and to get the resources for this video, visit jb.works and enter the TMT code shown below at the search prompt. An RC servo is a small box with an electric motor on one side and some gears on the other side. And what it lets you do is control the position of a shaft. And it does this by letting you turn it. And the servo will turn the shaft around from 0 to 180 degrees. And ordinarily these are used in things like remote control tanks, aeroplanes, etc. Now for the JackBord, we provide them mounted on a special RC servo aluminium plate, which makes it easier to attach them to the JackBord. And we also fit an arm for you. And again, these let the JackBord turn the servo through 180 degrees. Now you shouldn't turn the servo manually like I am here, but I'm just doing it to show you and I'm being very careful. But it's very easy to break the servo by turning it, without of course using the JackBord. What would you use the servo for? Well, this is one example. This is a Wi-Fi signal strength meter. And what this is doing is it's using the servo to point the arrow at an indicating scale of how strong the Wi-Fi is. And so essentially the better the Wi-Fi, it will point over here, and if it's really bad, it will point over here. And the servo is being used to move the arm. And this is one of many, many ways in which you can use an RC servo. So next, we're going to learn how to connect one to the JackBord. Just a quick warning, do not turn the shaft of the servo with your hands manually, especially when the servo is being controlled by the JackBord, because there's a good chance that you'll destroy the servo. For this guide, you're going to need a charged JackBord, 4 short female-female jumper wires, a dual servo USI. So what this guy does is he makes it easy to connect 2 servos at this end to the JackBord over here, and we'll learn how to use that later on. You need 2 M4 bolts, 2 M4 nuts, 1 M4 washer, spanner of some sort, an Allen key, and of course 2 servos. Now the servos that we have here are ones from JackBord, and they come pre-mounted on the aluminium plate, which makes it a lot easier to use them. Okay, first thing we're going to do is fit the servo USI onto the JackBord. And we're going to use port A to control the servo. So I'm just going to take a bolt, slip it into the middle hole, and then holding it with your finger, we'll just put the USI on top, and then we will just put the nut on. And that just makes it easy to put the other wires in later on, because this guy isn't going to be flopping all over the place. So we put them in kind of like, not terribly tight, but just enough to keep them still. So the next thing we need to do is connect the wires to the USI. So the first thing we'll take is a green wire and go from ground on the USI to ground on port A. You don't have to use the exact same colors that I do, but just make sure that the pin connections are the same. Now the next thing we're going to need is a 5-volt connection. So you see we've got a red pin on the USI, goes from there to the 5-volt pin on the JackBord. Then after that, we're going to connect the 2 lines, which are these 2 here, and these are the ones that control the servos. So the first one, put a white jumper there, and he'll go into port pin A2. And then lastly, we're going to take the green wire and plug it into port pin A1. So to summarize, we have a red 5-volt power line going from the red pin on the USI into the 5-volt pin on port A. Then we have a green wire going from the green pin into the green pin on port A. And then we have from port pin A2, we go into the white pin on the USI. And then lastly, from port pin A1, we go into the blue pins on the USI. So once we've done this, we will then connect the servo. Check your connections against these pictures and make sure that they match. And remember, you don't have to use exactly the same colored wires that we have here. The main thing is that the connections match. Next, we're going to connect the servo to the jackboard. So take one of the bolts, put it through at port B here, and then just take the servo and lay it on top with your finger underneath to support the bolt. And we fit the washer, and that just protects the metalwork of the servo. And then put the nut on. Oops. Put the nut on well. There we go. And then again, it doesn't need to be awfully tight, so just like loose hand tight. So now that we've got the servo bolted to the jackboard, the next thing we're going to do is take the servo cable and plug it into the USI. Now if you look, the cable has three colors. One is brown, which is ground. The other one is red, which is in the middle, and that's for the plus 5 volts. And then the last one is the orange, and this is this data wire, or the signal wire from the jackboard. So the power from the jackboard will go via these two wires into the brown and red wires, and the signal, because we're going to put this into the servo 1 position, will go through this blue wire and into the orange wire. So what we're going to do is plug the servo so that the orange wire is connecting to the blue pin. Okay? And that's the servo connected to the jackboard. Check the attachment of the servo to the jackboard and also the connection to the dual servo RSI using these pictures. And take particular note of the fact that the orange wire on the servo is right next to the blue pin on the USI. And if you're attaching a second servo at the same time, the orange wire of that second servo would go into the white pins. Now that we've got everything connected up, turn on your jackboard. Now that the jackboard is turned on, go to the command page on the dashboard. The first command we're going to use is the SVP, which stands for servo position. The arguments are the port that the servo is connected to and the angle that we want. The port letter is represented by the hash symbol and can be A, B, C, or D. And the pin is represented by the tilde, and that can be from pin 1 to 5. So for example, to use port pin A1, you would put SVP space A1 space and the angle. Now the angle is the shaft angle that we want between 0 and 180 degrees. So look at the commands on the top right hand side of your screen and we'll run them. So the first one is SVP space A1, and we have A1 because the servo is connected to port pin A1, 90. And this will set the servo's shaft at 90 degrees. Next, we run SVP space A1 space 180. And this will set the servo's arm all the way to the right at 180 degrees. And then to bring the servo's arm back to the far left or 0 position, we run SVP space A1 space 0. So essentially, the SVP command lets us set the angle of the servo to anything between 0 and 180. So to set it to 45, we type SVP A1 space 45. And the servo's arm will be at 45 degrees. The next command we're going to look at is the SVS command. And SVS stands for servo sweep. And what that means is that the servo will sweep its shaft starting at the start angle through to the end angle and then back again. The port pin is the same, which will be A1 in our case. The start angle is the angle we want the sweep to start at, and the end angle is the angle at which we want it to end at. The optional delay at the end is a delay that will be inserted between each 1 degree change in the servo shaft angle. On the dashboard, if we type SVS space A1 space 0 space 90, the servo will sweep from 0 to 90 and then back again to 0. If we then type SVS space A1 space 0 space 180 and press enter, the servo will sweep from 0 all the way around to 180 and then back again to 0. Now finally, if we wanted to add a delay, type SVP space A1 space 0 space 180 space 100. The 100 at the end will put a 100 millisecond delay in between each of the steps, and it looks like this. So the SVS command sweeps the servo's arm between two angles. Lastly, we're going to add a second servo. The dual servo USI can take two servos. This is the first one, and that's the second one. And the first servo is controlled by the blue wire, which goes into port pin A1, and the second one will be controlled by the white wire, which goes into port pin A2. So to start with, take the bolt and just put it into the side here. Take the servo. Actually, we'll connect it up the other way. And then we'll put the washer on and the nut. And again, it doesn't need to be really, really tight, just hand tight's fine. So that's the second servo. And connecting the cable is very simple. Just make sure that the orange wire is on the left, so that's on this side, and it plugs into these second pairs of pins here. There we go. So that's the first servo, and this is the second servo. And so now we have two servos being controlled by the one JackBord. Now that we've got the second servo connected, and it's this one down here, we can run the same commands as we did previously, but notice in the top right hand corner that we're using pin A2 instead of A1. So for example, to set it to 90 degrees, SVP space A2 space 90. And then to set it to 180, I go SVP space A2 space 180. And then back to 0 again, it's just SVP A2 0. To summarize, the SVP command, which stands for set servo position, sets the servo at the specified angle. The SVS command sweeps the servo's shaft from the start to the end angle, and you can add an optional delay. And make sure that you don't manually turn the servo's shaft because you might break it. Visit www.jb.works.